In this video, we're going to discuss arc length. Now, you may think that you know all about arc length because we've talked a lot about arc measure, but they're very different. Arc measure is a degree, so in red would be an example of arc measure, since consider that to be a central angle. I know it's not drawn perfectly, but if this was arc AB and that was 30 degrees, then the measure of arc AB is going to equal 30 degrees. But when we're talking about arc length, that's an actual length. So consider like this circle to be a park, and it's a circular park, and you want to walk from point A to point B. The arc length will be the distance that you're walking on that curve around the circle from point A to point B. So let's say that was 2 centimeters, then AB just equals, without the measuring symbol right here, AB equals 2 centimeters. So arc measure, degrees, arc length, how long an arc actually is, if you were like to straighten it out and hold it against a ruler. So arc length and arc angle, which we just referred to as arc measure, so that word arc angle, arc measure could be used interchangeably, are linked by a proportion. So as the arc angle increases, so look at that central angle, it's getting bigger, think what's happening to the arc length, and you should say that they're both getting bigger at the same time. Now, the only notes that you need, or the only tool that you need to solve and all of these problems, is this proportion right here. The central angle over 360 equals the arc length over the circumference. And let's think about why that makes sense. So let's say we have a circle, alright? And we have a central angle, and we'll start off easy. We'll say it's just a 45-degree central angle. So the central angle over 360, well, that's going to equal 1/4, obviously. And if you look at the circle, this green arc that I'm highlighting right now, we'll call it arc AB, is 1/4 of the entire circumference. So if this entire circle had a circumference of 4, then that would imply that the arc measure of AB would have a measure of 1. So the arc length divided by the circumference would also be 1/4. So just think back to that easier example, why it makes sense. The ratio of the central angle over 360 equals the arc length over the circumference. And it's also because 360 and circumference both represent the entire circle. And arc length and central angle both represent just pieces of the arc. Alright, so let's try a couple problems, and all we're going to do with these problems is just use this proportion I just explained to you, plug in what we know, and solve for what we don't know. So a monkey walks around the circular cage. This is the same as walking 300 feet around the cage. What is the circumference of the cage? So, we know a few things. We know that this angle right here is 300. So from here to here, it's a pretty big angle. And this distance, so we got a circular cage, and the monkey walked around the perimeter, is 16 feet. And we want to know the circumference. We do not know that. So how are we going to solve it? Well, we're just going to use the proportion from the previous page. The central angle, 300 over 360, that ratio, which comes out to about 10/12, so this is 10/12 of the entire circle, is going to equal the arc length, which they gave us, 16, over the circumference. Alright, that was the hard part, setting that up. Now the easy part, we're just going to cross multiply until we get C alone. So 300 times C equals 360 times 16, and then divide both sides by 300. And then we get the circumference equals 360 times 16 divided by 300. So if you type that in a calculator, you get a number, which is 19.2. Alright, so that's one type of problem where they'll always give you 2 to 3 things in this proportion. Right here. They'll always give you 2 of the 3, either central angle, circumference, or arc length. So in the previous question, they gave you the central angle, they gave you arc length. We know 360 is 360, so circumference is what we're looking for. So all questions should always be like that, where one of your numerators or denominators should be a variable, and you cross multiply and solve for it. So let's try 2 more problems just to make sure you got the hang of it. If you feel like you got the hang of it, then feel free to pause it, try the problems right before I go over them, and then hit play to see the answer. So if you just tried that problem, now it's time for the solution. So we have a crop circle, and a farmer walks 90 feet around the circle. So let's try to highlight that in red so it really sticks out. Alright, so from here to here is 90 feet. And that's equivalent, 90 feet, not degrees. I'm just so used to writing 90 degrees, I guess. So 90 feet. Sorry for stalling right now. I just want to erase that little pet peeve of mine. Alright, so that little arc is 90 feet. And it's also given that the arc measure is 2 degrees. So that means that this central angle is 2 degrees. How long is the diameter in miles? So you might be thinking that that proportion that we know, that I'll abbreviate up here, central angle over 360 equals the arc length over the entire circumference. You might be wondering, well, there's no diameter in that, so how are we going to figure out the diameter? Well, you just have to find the circumference first, and once you know the circumference, you can figure out the diameter pretty easily. Since circumference is diameter times pi, if you know the circumference, you divide it by pi to get the diameter. So let's use this proportion up here and solve for circumference. So the central angle is 2 degrees, and that's 2 degrees of the entire circle, 360 degrees. The arc length, 90 feet. The circumference, we don't know. So we're going to solve for that. So 2c equals 90 times 360, which comes out to 32,400. Divide both sides by 2, and we get circumference is, sorry about that, 162,000. So since circumference is diameter times pi, and we know that the circumference is 162,000, we could just divide both sides by pi to figure out the diameter. So the diameter is going to be 162,000 divided by pi. So 162,200 divided by 3.14 gives us 5,159.2, we'll round to one decimal place, 0.2 feet. Alright, so that would be our answer. So anytime they ask you in these arc length questions for diameter or radius, just find the circumference, and then you could figure out the diameter or radius by dividing by pi, and then if it's the radius, you could also divide by 2. Alright, one more. And again, if you want to try this problem, pause it, and I will show you the solution. So, the radius to the circle is 12 miles. We want to find this arc right here from A to B. We don't know the central angle. You can't just use this 50 degrees because the central angle is proportional to the arc length, not the inscribed angle. So we can use that inscribed angle to help us figure out, well, since this inscribed angle is 50 degrees, this arc measure has to be 100 degrees, so this central angle has to be 100 degrees. So we know the central angle, is 100 degrees, and we also could figure out the circumference. Since the radius is 12, the diameter is 24, so the circumference is 24 pi. And we know the entire circle is 360, so now we're just going to find the distance from A to B, which is the arc length. So we're going to set up the proportion. This arc length is 100 degrees of the entire 360 degrees of the whole circle, and the distance from A to B is an arc. So we don't know that. That's the arc length. We'll write x in for there, and the circumference is 24 pi. So now we're going to cross multiply, solve for x, leaving x in terms of pi whenever possible, just because it's just nicer because it's an exact answer. You don't have to worry about rounding errors. So if we divide both sides by 360, we get that the arc length is 2400 pi over 360. So to leave it in terms of pi, the only thing I'm going to type in my calculator is 2400 divided by 360. And that comes out to 6.66. So we can round that to 6.7. And then the pi just kind of stays there. And it comes out to 6.67 pi. Now a better way to do this, honestly, would be to simplify this fraction that I kind of put parentheses around in yellow, and then write that in terms of pi. So like your answer would come out to like 20 pi over 3. So it's another acceptable answer. Alright, I hope this video was helpful. Email me if you have questions, and let's make sure this is the last slide before I officially sign off. Yep, it is. And alright, that's it. Have a good one. Oh, let's get 10 minutes exactly. Stop. Oh, went over. How'd it go?